Welcome everyone. Hopefully you're all doing well. So today's going to be a review session, and I'm going to be finishing up chapter 8. So this is something you can reference. The best way to utilize this video is anytime I do practice problems, try to pause the video, do the problems, and then go back and check my work. So I'm going to try to walk you through step by step. There are some things that I'm going to just display on the screen just for you to see. And then I'll tell you what to write down, very similar to what we've been doing in class. So the first problem we're going to do is we're going to finish up a practice problem for chapter 7. I mentioned how this could be something very exam-like. So remember, anytime I say that, make sure to take notes on that. So this problem is how much money does a typical CSULB student spend at the student union on a campus per visit? The amount is normally distributed, so that should be a key word there. And then I provide you with a sample, and we're going to assume that it's the entire population. And I give you 5 entry points, so $10, 7, 5, 13, and 15, and I ask you 2 questions. So if I was attacking this question, what I would do is I would look at the 2 questions first. So find the probability that student spends less than $850. So I would set up the probability statement. Try to make it as easy as possible for you so you know where to go from here. So it's the probability that X is less than 850. The reason why it's less than, we see less than. And the next question, find the probability that a student spends more than 1050. So the probability that X is greater than 1050. Now, we talked a lot about the complement rule last time in class, and you know that the only time we use complement rule is when it's more than. Only time, not for less than. All right, so I'm just gonna flash the steps. These are steps that you should have pulled up somewhere. This should be on your cheat sheet for the upcoming exam. It's going to help you on exam 1, exam 2, and the final. But highlight the important information, set up the probability statement, standardize probability statement in terms of Z, decide if you need to use a complement rule, find the probability, add context to the problem. Now, if we go to this problem, what we're doing right now, there's one extra step that I've added to this, and that is finding the mean and the standard deviation. So the population mean, this is where you can pause the video and you can go back in and try to find the answer. So the population mean is mu. It's a summation of xi divided by an uppercase N. So again, the reason why it's uppercase N for this problem is assume the sample is your entire population. If I ever say that on an exam, hint, hint, you're going to be using the population level formula. That's for mu. And then for our standard deviation, in order to get to standard deviation, we know we have to have variance. So the formula for population variance is here. And it's all over the capital N. Remember, if you look back to sample variance, go back in your notes, look at sample variance, it's lowercase n minus 1. The biggest difference here is it is a capital N and you're not subtracting 1 from it. And then if we want to get our population standard deviation, you just take the square root and you'll be given your population standard deviation. So you're going to be using these values. You know how to use the summation operators. You know how to find the values for this. So I'm going to put up the answers up here on the screen. You can double check your work. So the population mean after you do the calculations should be $10. The variance should come out to $13.6 squared. And then your standard deviation should come out to $3.69. So this is after you employ all of these formulas right here, and you're using this data set. All right. So from here, if you want to continue on, I would encourage you to pause the video and do these two problems here, given the information up top. But do practice calculating the mean, the population variance, and population standard deviation. That is something I will test you on. Just double check if you can get those numbers or get close to those numbers. And then when we meet, you can ask me questions, so forth. All right, so we're gonna do the first one. Just gonna blank out my screen real quick. All right, so the first question is, what's the probability that x is less than 850? So you set up the probability statement. That's step one. We want to transform x into z. So we want to standardize x minus mu over the standard deviation is less than 8.50. And we've calculated the other values. So it's 10 over 3.69. If I reduce all of this down, it's going to be the probability of z being less than negative 0.41. So you should be getting something close to that. And then from here, because it is less than, we can just go straight to our table and we'll have our answer. We don't need to do any more math. You go straight to the table. So if I look this up on the table, the probability should be 0. Should be 0.3409. And then you can add context within the problem. All right. I'm not going to sit and add the context, but that is something I expect you all to do. For the second problem, it was, what's the probability that they spend more than 1050? Because it's greater than, eventually you're going to have to use the complement rule. So we still have to standardize, same steps. So x minus mu over the standard deviation is greater than 1050. And we subtract this by 10 divided by 3.69. These are the values we calculated earlier. If I reduce this down, it's a probability of z is greater than, I believe it should be 0.15. I'm going to double check it really quickly. It should be 0.14. That is on me. So its z is greater than 0.14. We know we have to use a complement rule, which means 1 minus the probability of z being less than 0.14. So you notice the only difference between these two is you're flipping the sign. That is the complement rule. I find this on the z table. And if I look that up on the z table, it's going to be 1 minus 0.5557. And if I subtract that through, the answer I'm going to get is 1 minus 0.5557 is 0.4443. So you should get an answer somewhere along those lines. If we got both those answers correct, awesome, great job. If you didn't, go back, double check your work, walk through the steps. That's the main thing, is walking through the steps. All right, and then we have this other practice problem, looking at proportions, very similar. I give you the information like the mean and the standard deviation. You should be able to walk through this. And then we will talk more about this at another point in time, but this is just another practice problem that you can do. All right, so there's other types of distributions as well. We have student t distributions. This is when we look at means. We have chi-squared, which is going to look at variance. And f distributions is when we look at two variables at the same time. So eventually, we're going to have a table associated with each of these distributions. And it's going to be the same steps. You start with the probability statement. You standardize. You find the probabilities or the area underneath the curve, and we go from there. So for the next like 6 weeks, we're going to be doing the same exact thing. So that's essentially all of chapter 7, everything that you need to know. Make sure you go do the practice problem. We're going to start chapter 8, just so you have something to reference. This is going to be a big part of your upcoming exam as well, like I mentioned. So sampling distribution, what we're looking at now is sampling techniques. So every time you draw a sample from a population, values are going to change. So probability can be associated with this. So we can draw a sample from a sample size in a population, and we can calculate statistics and then use descriptive techniques in some way, shape, or form. And we can use expected value and variance for this. So if we were to consider a roll of 1 or 2 dice, if we were to find the probability of just getting one outcome within a die that's thrown, the probability is 1 out of 6. So the probability of getting a 1, you only have 1 out of 6. If I were to add another die to this, so we have 2 dice now, the sample mean is going to change. So if you look at this table, you'll see where it says sample. If your first outcome is a 1 and a 1, the average of that is 1.0. And as you go down, you'll see that your average changes, right? So all the different outcomes that you could possibly have. Now, if we were to map this out and create a distribution, you'll notice you have a bell-shaped distribution. So the bell-shaped distribution, that should signal that it's normally distributed. Anytime you see normally distributed, the first thing that should come to mind is like, hey, I can use tables, I can use statistical techniques, I can use all these different things. You can use coding to help you with this. So on the left-hand side, you have a single sample distribution. On the right-hand side, you have the sampling distribution of the sample mean. So one thing I want you to make sure you have, it's actually on this slide. So what I want you to have is this bottom portion. This is going to be some of the formulas that you're going to need to know. So what this is saying, what this is reading is the population mean of the sampling distribution, or the population mean of the sampling distribution of the sample mean. So you see the mu, and then you see the x bar, the subscript x bar. When you see the subscript x bar, that means you're working with the sampling distribution of the sample mean. I know that seems like a lot of words, but it is very important. There's a distinction. So the mu subscript x bar, so it's right here on the left-hand side. It's saying the population mean of the sampling distribution of the sample mean. Now, what this statement is saying right here is the population mean of the sampling distribution of the sample mean is equal to the population mean, meaning whatever my population mean is, assume that it's the same. This bottom portion right here, this is your population variance of the sampling distribution of the sample mean. Now, this is important because what we want from our population variance is our population standard deviation. And in this chapter, we call this the standard error. So what this is called, you can call it standard deviation of the sampling distribution of the sample mean, or you can say standard error. So the formula for standard error is standard deviation divided by the square root of your sample size, that lowercase n. So these are the formulas you're going to be using, and this will be important. So we're going to assume the central limit theorem. So essentially what this means is as we increase our sample size, we're going to have a more normal distribution. So in theory, as we get more and more of the population to be included in our sample, we're going to get a better representation of the entire population. So as sample size increases, this is why we want large sample sizes. You don't want a small sample size due to it not representing the entire population. But as you increase sample size, you have a more normal distribution. Don't need to know that. Okay, so we covered this before. Now, this slide, I want you to have down word for word. So you'll see on the very top, it says sampling distribution of the sample mean. This is how you calculate, this is how you standardize for this chapter. So think back to the last chapter. So chapter 7, our standardization formula was z equals x minus mu over the standard deviation. Chapter 8, the new formula is x bar minus mu over this. So x bar, we know what x bar is. We've worked with x bar before. In your head, you should be thinking sample mean. X bar is sample mean. Mu, again, we talked about mu, population mean. This bottom portion right here, this is your standard error. This is what we just introduced a couple slides ago. So that is your standard error. These are both the same thing. That is your standard error. So this is the way you're going to standardize now for chapter 8. And what gives it away, we'll do practice problems, and I'll show you the difference between chapter 7 problems and chapter 8 problems. There's a clear indication that there's a difference. And you look at the keywords. So this slide, very, very important. Super, super important. You need to have this. This should be on your cheat sheet. These are basically the steps for standardization for chapter 8 when referencing the sampling distribution of the sample. So you're going to highlight the important information. You're going to set up your probability statement. So the probability is where it says x bar, that just means sample mean. So another way of writing that is x bar is less than x, or the probability that x bar is greater than x. So our goal is to standardize x bar and turn it into z. The formula we use for that is x bar minus mu over the standard error. Now, this is also the same as saying this. So this is both the same thing. These are both the same. This is just, this formula right here is more in depth. I would encourage you to use this one, but know that both of these are the same. After you get past the standardization step and you set up the probability in terms of z, it's all the same stuff. The only thing changing is the setting up the probability statement and standardizing. That's the only thing. Everything else remains the same. So we have our first practice problem, and we're going to read through this and look at the important concepts. So the foreman of a bottling plant has observed that the amount of soda in each 32-ounce bottle is normally distributed. So keyword, normally distributed. It has a mean of 32.2 ounces and a standard deviation of 0.3 ounces. And I give you 3 questions. So the first question, if a customer buys 1 bottle, what is the probability that the bottle will contain more than 32 ounces? So this should seem pretty normal. This is like a chapter 7 problem. If I just were to show you this, this would be a chapter 7 problem. What this is asking is what's the probability that X is greater than 32 ounces. So you should know how to do this first one. Pretty straightforward. Now, the reason why it's X and not X bar is because this right here. It says 1 bottle. So the sample size in this problem is just 1. We're just focusing on 1. If you look at the next 2 problems, you'll see stuff is bolded and italicized. So if a customer buys a carton of 4 bottles, what is the probability that the mean amount of the 4 bottles will be greater than 32 ounces? So what gives this away that you're working with chapter 8 and sampling distributions of sample means is you'll see that n now is what? N is going to be 4, right? So n equals 4. And then also the keyword that tells you I'm working with sampling distributions, you'll see mean amount. When it says mean amount, you're working with X bar. So what this question is asking you, and the way this would be set up, is what's the probability that X bar is greater than 32 ounces? So they look very similar, but the X bar is very important. For the first problem, the standardization formula would be X minus mu over your standard deviation. For this question, it's X bar minus mu over the standard error. So there's a difference in the way you do the first couple steps. So down here, the n would be 4, and that's given to you in the problem. And then if you look at the next problem, this is also a chapter 8 problem. So n, you see, is 30 bottles. So n equals 30. And it says, what's the probability that the mean amount, so mean amount gives it away that it's chapter 8, will be greater than 32 ounces. So now it's the probability that X bar is greater than 32. Well, you might say, okay, well, question 2 and 3 are the same because they both ask for 32. Yeah, to a certain degree, but the main difference is the sample size, right? So 4 and 30, there's a huge difference. So the standardization formula we're still using here, X bar minus mu over your standard error. Okay, so if we're doing the first problem, if a customer buys 1 bottle, what's the probability that the bottle will contain more than 32 ounces? What you can do is pause the video, do this. This is chapter 7 stuff. You should know how to do this. I'm going to flash it on the screen. So when the probability of X is greater than 32, normally distributed, we standardize using this formula. This transforms into Z. We reduce this down. What we're going to get is a probability of Z is greater than negative 0.67. Because it is greater than, we have to use the complement rule. So 1 minus 0.2514. This 0.2514, I found this on the Z table. The way you found this on the Z table is you're trying to look up 1 minus the probability of Z being less than negative 0.67. So if I find this portion on the Z table, it's going to return the 0.2514. And then you add your context, you're good to go. This is stuff you've seen before. Now, if the customer buys a carton of 4 bottles, what's the probability of the mean amount? So the mean amount should give you the X bar. That's what you're focused on now. The steps are, you can pause the video, go ahead and do it. Remember the standardization formula is Z equals X bar minus mu over the standard error. All right. So it is up here on the slide. So you set up your probability statement 1, right? So it's going to be probability of X bar is greater than 32. Step 2 is to standardize. So you'll see X bar minus the mu of X bar divided by this right here is called the standard error. Remember, we showed you that before. If you want to expand on this, it would look like this. So the probability that X bar minus mu over standard deviation over the square root of n. And that's greater than 32 minus 32.2. And if I were to divide that by the 0.3 over the square root of 4, I got all this from the problem itself. If I reduce all of this down, it's going to turn into the probability that Z is greater than negative 1.33. Once you get to this step, you should know what to do from here. This is the only step right here that's changed. Everything else remains the same. Because it is greater than, we have to use the complement rule, right? That's one thing that's missing up here. So the complement rule is 1 minus the probability of Z being less than negative 1.33, and it equals some value. So what I want to do is find this value right here in the Z table. So if I go to the Z table that I've given you, which I think I lost. So negative 1.33. It's going to be 1 minus 0.0918. If I subtract that through, I'm going to get 0.9082. And then you add context. Now, this is going to be the same exact for the next step, right? For the next question, at least. Oh, the next question is not up here. But the only thing changing for the 4 bottles for this problem would be this turns into 30. That's what the problem says down here. So as I change that to 30, the only thing changing my entire problem is this portion right down would be right down here. That's the only thing that's changing. And that would change your Z, that would change this, that would change this, and that would change this. So again, you can do another practice problem. From what I've given you so far, you should be good. But go in, do those problems, and we'll review it again when we meet. All right, so again, these are the steps for standardization for sampling distribution of the sample mean. So you'll see X bar. When you see X bar, you're working with sample means. The only thing that's different are these 2 steps right here, but slightly, like I mentioned before in the video. All right, so we have some practice problems for this. Give me 1 second. All right, so the first problem is, what is the probability that a professor works more than 60 hours per week? And then the second one is, find the probability that the mean amount of work per week for 3 randomly selected professors is more than 60 hours. So you should be able to ask yourself, well, what's the difference between these 2 questions? The first question, it says a professor. So N should be 1, right? So N equals 1. And it says more than 60 hours. So for question 1, the question's asking, what's the probability that X is greater than 60, right? And then for question 2, what gives it away is mean amount. And it says 3 randomly selected professors. So now it's the probability that X bar is greater than 60. And then, N equals 3. All right, so you can pause the video, do the work, and then answer the question. I'm going to put the work on the slide, and then you can double check your answers as well. So you standardize both. So X bar minus mu, standard deviation greater than 60 minus 52. I got 52 from the problem itself. Standard deviation here as well. If I reduce all this down, it's the probability that Z is greater than 1.33. Because it's greater than, we have to use the complement rule. And then our answer is going to be 0.0918. So if I look this up on the table, it's 0.9082. And then you can add context. So like the probability that a professor works more than 60 hours per week is roughly 9%. For this one, we standardize. So X bar minus mu over the square root of N is greater than 60 minus 52 over 6 divided by the square root of 3. The 3 is the N. If I reduce this down, it's a probability of Z. This all turns into Z. This all turns into Z. And if I reduce this down, it's greater than 2.31. And from here, you should know what to do. Complement rule, probability of Z is less than 2.31. if I look this up on the table, it's going to be 1 minus 0.9896. If I do the actual math, it comes out to 0.0104. So the context would be the probability that the mean amount of work per week for 3 randomly selected professors is more than 60 hours is roughly 1%. All right, the next part of chapter 8 is the sampling distribution of a proportion. So this is the last part of chapter 8. Before we were looking at the sampling distribution of the sample mean. Now we're looking at the sampling distribution of a proportion. So when you look at a proportion, you need p hat. P hat is a number of successes in a sample. So x over n will be your p hat. So you need to know this. This will show up on the exam. For this, we have a new way to standardize. We have the expected value of p hat is also your proportion. You have your variance of p hat, which is a formula up on the slide. And then now we have the standard error of the proportion. So this bottom portion right here, this is the standard error of your proportion. This is something you'll need. So anytime you see p hat, it's the square root of p1 minus p over n. So p, remember, is your sample proportion or the number of successes in a proportion. And then this is very similar to the standard error of the sample mean. So remember, this symbol is for this right here. This was for the previous one we just did. So they're very similar in terms of their symbol, but the setup is a little different. All right, so the way we standardize now is this right here. This is our new standardization formula, which you need to know. So you'll need to know all of these. So p hat, the way you find p hat, it is x over n. P, this is your population proportion. This will be given to you in the problem. So P will be given to you in the problem itself. So here we have our setup. So these are steps that you need to know for chapter 8 as well. Again, the only thing that's changing is the first couple steps. That is it. So the first one is the probability that p hat is greater than some value, or less than, or probability of p hat being less than that value. And you want to transform p hat into z using this formula. So remember that this formula is square rooting the entire thing. From there, the steps remain the same. And again, we will do practice problems again when we see each other. All right, so we're gonna do a practice example. In the last election, a state representative received 52% of the votes cast. 1 year after the election, the representative organized a survey and asked a random sample of 300 people whether they would vote for him in the next election. If we assume that his popularity has not changed, what's the probability that more than half of the sample would vote for him? So essentially, what it says is what's the probability that more than half of the sample? When it says more than half of the sample, that means more than 50%. So we're working with proportions. What gives it away in the exam question and practice problems is you'll see proportions and you will see like more than half of the sample, something along those lines, or a percentage. So in this case, the problem's asking you what's the probability that p hat is greater than 0.50. On the exam, it'll be much more clear cut. So it's going to be P hat is greater than 0.50. Now that's what the question's asking you. It'll tell you itself in the question. And I'm going to show you another one. I'm hoping we'll come back to this in just a second. Okay, so this is an example right here. The manager of a restaurant in a commercial building has determined that the proportion of customers who drink tea is 14%. What is the probability that the next 100 customers, at least 10%, will be tea drinkers? So there's a couple things missing here. It will say normally distributed, but the reason why you know this is working with p hat, you see proportion, and then you see a percentage. So the keywords are proportion or percentage. So in this case, what's the probability that p hat is greater than 0.10? So that's that 10%. This portion will always come from the problem. So we're gonna go back to the other one. I just wanted to show you how this is more exam-like. All right, so for the sample, more than half the sample, we know that p hat is greater than 0.50. The p is given to us in the problem, right? So the p is given to us in the problem itself. So this 52% is our p. So when we do our calculations, so we start here, the probability that p hat is greater than 0.50. That's step one, right? That's given to us in the problem. Step two is we want to standardize. So we want to transform p hat into z. So the only way we can do that is using this formula. P1 minus p over n. We do that same thing to the other side. So what's given to us right here in our formula is our p hat. So what our question's asking, that's what we're assuming to be true, or what we want to test. So 0.50, and you subtract this by p. So your p hat in the problem is what you're testing, which is 0.50. The p, this is what's assumed to be true. This is the actual population proportion. And what we're assuming to be true is what's given to us in the beginning of the problem is 0.52. And you plug everything in. So 0.52 over 0.52, 1 minus 0.52. And it says 300 people. And again, I'm getting all that from the problem itself. So it says random sample 300, p is 0.52. And then what we want to test is what we assume. We want to find the probability that more than half the sample. So these are all the things you need to know. If you reduce all this down, it comes out to the probability of z is going to be greater than negative 0.69. After you get it to this step, it should be like clockwork. You should know what to do from here. You know that you need to use the complement rule. So 1 minus the probability of z being less than 0.69, negative 6.9. And if I find this up, if I look this up on my z table, I should get one minus 0.2451. If I subtract it through, I'm going to get 0.7549. And the correct answer in this case would be the context below. All right, so we're going to do the T example. Which is right here. So the probability that p hat is greater than 0.10. So from the question, determine that the proportion of customers who drink tea is 14%. So this is what we're assuming to be true. This is the population proportion. So that 14% is 0.14. That is our p. Our p hat is what we want to test. So what's the probability that the next 100 customers is 10%? So our p hat in this case is 0.10. And then our N is in the last question right there. And it says 100 customers. So 100. So now what we're trying to do is find the sampling distribution of the sample proportion. So same steps, we standardize. So the probability, you can pause the video and do the problem, then check with me. P hat minus P over the square root of P1 minus P over N is greater than 0.10. We subtract this from P, 0.14. The biggest mistake students make here is putting this denominator in their calculator. So parentheses, super important. And we will do practice with this in class too. All right, if I reduce all this down, it's the probability that Z is greater than negative 1.15. Again, once you get it to this portion right here, you should know what to do. So it's the probability, or it's 1 minus the probability of Z is less than negative 1.15. The reason why we do the opposite sign, complement rule. So it's 1 minus, and if I look this up on the table, it's 0.1251. If I subtract it through, I should get 0.8749. So again, that's all of chapter 8. You need to know the sampling distribution of the sample mean, sampling distribution of the sample proportion. The steps, very similar in a lot of sense. But here, what we're doing is the first two steps are a little different. So P hat, P, and then your Z is a little different. But overall, once you get it past that point, it's all the same stuff. So again, on your exam, one thing I will tell you for your cheat sheet. So give me one second. If this is your cheat sheet, what I would do is like right here, have chapter 3 formulas, right here, chapter 6, right here, chapter 7, and then right here, chapter 8. What I would do is I would fill in all the steps that you have, and underneath the steps, put in like the formulas, put in different parts that you think are going to be the most helpful. This is going to have more organization, and you can reference like, hey, I know I need to go to chapter 3 stuff, so I'm going to look here. Or I know I need to look at chapter 7 stuff, I'll look here. Or chapter 8 stuff, right here. That's what's going to help you the most. If you have any questions, feel free to send me an email. But yeah, you all should be okay. I hope this video does help. I'll see you all very, very soon.